Oh. What does the word fundamental mean? Your basics, right? If you're talking football fundamentals, it'd be like tackling, throwing, and catching, stuff like that, right? Your basics. The things that everything else is based on. Gravitational force. It's a good looking force. It's attractive. Like that one? No? Gravitational force. It's an attractive force. It attracts things. It also exists between all objects. I am attracted to Dan's Tim Hortons cup. There's a sentence you've never heard before. I was about to ask, why do you think I'm attracted, but I'll rephrase it, because that might get me in some trouble. How is there, or why is there an attractive force between myself and Dan's coffee cup? And let me back that up one step further. Is the coffee cup attracted to me? It's an inanimate object.
Yes, it is.
It is attractive. Look at it, see? Thanks, Dan. Thanks for pointing it out. It is indeed attractive to me, but not near as much as Dan, sort of, right? How much force is there between me? Is it really small or really big? Really, 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 really small. And who has the greater force of attraction, me or the cup? I'm bigger. But not near massive enough for the cup to come flying forward, thankfully. Okay? The gravitational force between the center of the Earth and objects near it causes objects to fall toward the surface of the Earth. I'll put air quotes around the word near while I go over here to get my tennis ball. The plan is they're going to start calling classes around 9:30. Based on the last time, we didn't get called until about 9:45. So I'm going to try to get this set of notes done regardless, okay? You can just leave your books here. I'll lock the door, take your valuables with you, and then you can come back when it's over. Grab those. Okay. If I drop the tennis ball, it falls. How come? Earth's gravity, right? Gravitational force between the center of the Earth and objects near it cause objects to fall towards the Earth. If I put the tennis ball even higher, does it still fall? Well, sure. How high do I have to go before it doesn't fall? A couple of miles. Anyone want to disagree, or a couple miles is about it? The question was, how high do I have to go? Like, if I could go up in a weather balloon, how high would I have to go before the ball wouldn't fall? Maybe more? You have to leave the atmosphere. Pardon me? Okay. What if I was like somewhere near the moon? Would I still be attracted to the Earth? Okay. A little bit, but not as you get farther away. This is sort of leading into the gravity, and I don't want to get too much into that. As you get farther, let's just leave it at that for now. I'll get into that next week. As you get farther away, the gravity decreases. I'll work on those misconceptions. Unfortunately, down a couple miles is going to do it. Yeah, you realize that. And actually, out of the atmosphere, isn't going to do it either. It's a little bit more.
What is this?
You know, I don't know. Just off the top of my head. It's one of the weird things that I don't know. It looks like that, okay? You don't even need to draw that. We're going to get to that when we do the gravity. But suffice to say, everything is attracted to the Earth, right? Okay, let's leave it at that. Okay, the second one, and I do apologize for the length of these here. Physics notes are like bananas. Did I tell you this already? You know why? Because they come in bunches. I'm on a roll today, eh? Well, you know, I can somehow slip it in the lessons. I was right, they're not jokes. Thanks, Josh. Electromagnetic force. Can't do it. Electromagnetic force holds matter together. That's what's holding Josh together. Otherwise, he'd be a whole bunch of different Josh molecules just floating around. Holds matter together by providing the force that binds atoms into molecules. The force between particles of opposite charge is attractive, you know that. Positive attracts negative. And the force between particles of the same charge is repulsive. Ooh, yes. Positives don't like each other, positives, and so on, right? I'll go through an explanation of this in a minute or so when you're done. The strong nuclear force holds protons and neutrons together in the atomic nuclei. It is the strongest force out there. The strong nuclear force is the strongest one of the bunch. Okay, so far we've got three. You probably only really came up with gravity when I asked you what for. Any wild, crazy ideas what the last one might be? Probably not, eh? I move on here. Just looking around. I'm looking for people still writing. I don't see anyone. Last one. The weak nuclear force. The weak nuclear force is responsible for some kinds of radioactive decay, such as the decay that creates radon gas. Interestingly enough, occurs underneath your basement, much to the detriment of our health. Some of you may have a radon gas detector or a radon gas system in your basement. Anyone? No? Pardon me? Oh, you have to sneeze. It's not the radon gas. Radon gas is specifically quite bad in Manitoba, especially the Dauphin area. And I hate to tell you this, it causes lung cancer. It's actually quite high in my house. I have to get it fixed. So it's uranium, it's different materials underneath the basement of your house, and it leaks through your concrete floor. So that's the weak nuclear force. It's the next to weakest force, acts only when particles are close together. This is probably the most boring lecture there is. I apologize. Okay, so the outcome is identify the four fundamental forces of nature. Have we done it? Have we identified them? Yeah. Was it boring? Uh-huh. Do you need to know this for the future? No. Complete waste of time.
Is it going to be on the test?
Oh yeah, gotta be on the test, right? I have to evaluate it. Can you identify them? Well, I hope so. You get a cheat sheet on the test. I mean, my goodness, if you can't get this, right? I might ask you a question like, which one is responsible for radioactive decay? I might ask you that. Oh, don't, there's one more slide. Oh no, there isn't. Oh, because I usually ask at this point. Oh, this must be the. This isn't the right set of slides. Because I usually ask. Go back. We got time. Go back. Yes. Oh, there it is. Was that Josh? That's what I wanted to know. I'm going to make you think. We're going to put them in order from strongest to weakest. Just give me 30 more seconds here. Your mom can wait. Or are you checking the stock portfolio? Yeah. Price of Canadian dollars up. 78 cents last night I heard. Okay, which one did I say was the strongest? Strong nuclear. And I said, it's right on this slide, next to the weakest force. So we're going to put weak nuclear there. So which one is the weakest? Gravity, exactly. Gravity is the weakest of the fundamental forces. And which one goes in here? Electromagnetic. Okay? When I say fundamental, what I mean is all other forces. I asked you at the start, what are the four fundamental forces? Laura said gravity. She was bang on. Then we got a little bit tricky. Dan started reading me out the outcome of this, and he came up with the force of friction. The force of friction is based on, fundamental means that everything else is based on that, right? So which one does friction most align to? Like what is friction based on? Gravity, right? Pushing things together, right? I would also say electromagnetic, right? It's holding things together, right? When you rub something on another, right? It's holding it together. You actually are having a greater force than that holding it together, because like when you rub like sandpaper over a piece of wood, it rubs off some of the wood, right? Okay, that's about all you really need to know about all that.